Okay, so good evening, guys, and thanks for joining. It's been very late today. I requested all of you to join at 8:45 p.m. night, and you all have joined. I'm thankful for that. And I still remember, like when I was recording Kubernetes, right? It's almost like more than 1.5 year. And sometime I have asked my friends and all to join by 10 o'clock night. And if you watch the Kubernetes series, right, you some of the series you would see that actually I started the class at 10 or 10:15, and the people were available up to 12:10 night midnight. So one session I remember it went for 1 hour 50 minutes. I don't remember which was that session, but I remember the time. So that time it crossed about 12, and I could see all of my friends who attended my session, right? They all were they were enthusiastically, they were sitting and they were hearing to me, and there were no complaints. Nobody said that, Rajesh, it's late night and no, you can stop the session. They said that, they already told me that no, you continue your session and you complete it whatever possible. So I just remember that day. So, and thanks for all of you for joining so late actually. So in yesterday's class, right, in our DevOps Day, Foundation Day 4 session, we had understood about the computing models, right? What are the computing models? So basically, we have a simple client and server architecture, and we have a distributed system. Plus, we need not to really know about the peer-to-peer systems, but yes, yeah, that system do exist, right? And we discuss something on the clustering part, right? What exactly is clustering all about? This is what we had learned, and I said very important thing that being a DevOps engineer, we should know like how to do a code build and packaging actually, right? Code build and package. This is a very important aspect for every DevOps engineer, because like whenever the developer writes a code, right? Finally, you need to take that code and you need to compile that code, or you need to compile into a format where you can deploy the code into the server, right? And finally, what happened, right? You need to do a lot of various other activity, like either it could be a testing or something, and certify saying that the whole feature or the product is working fine. And finally, we take up the same code and deploy it into a production server. So this is what we do, and this is what the DevOps, it is one of the very basic or bread and butter activity of each and every DevOps engineer. It means that whenever any piece of code is given by the developer, a DevOps engineer has to go and compile it, build it, we say, create a package and deploy into the server or into the target server or into the some kind of environment, we say. So that is one of the activities. So what we would be learning or understanding further is that actually what are the processes, or is nothing but how exactly the DevOps engineer does build and packaging the code. So today is a DevOps foundational day 5 session, and it's 8 o'clock, 8 a.m. Sorry, 9, almost 9 p.m. IST.
Sir,
Yes,
it's
sir.
28. 28.
Oh, sorry. I'm sorry. Yeah, thank you.
Okay.
It's 28. Yeah, thank you. Okay. So now, so what exactly is that? We need to understand how to do a build and package the code. I mean, I'm not showing any practically. Later we will do it in upcoming session, but theoretically I'll explain it. Some of you, I think, already know about this because you have been working as a DevOps engineer, right? But still, okay. So we'll try to understand. So if I want to understand you in a pictorial form, so let me open MS Paint. So let me try to take some icons. So I'll go with the developer icon. Okay. So this person looks a developer. So he's a developer. Okay. So he's a developer who writes the code. So this fellow is a developer who writes the code, right? Who writes application code. So he can choose any language to write the code, right? He can use Java, C, C++, Node.js, or Python. Any language he can use to write a code. And once you write a code, right? Obviously, he's writing a code for an application. And finally, that application will be used by your end customer or by some user actually. So here you have something known as a user. So he's a user actually. So we'll take this person as a user. So, or else let me take some other picture. Yeah, this person looks okay. Um, Not seeing a proper face actually. I need a complete proper face. Okay, it's not there. It's not there. Okay, I'll take this as a user. Sorry. So he'll be the end user, right? Or he'll be the customer, right? Who will be using the application? Who will be using the application? So now when a developer writes a code, right? So you know that whatever the language they use, right? Suppose a developer uses a Java language to write a code, he cannot give the complete Java code to this end user, right? Because the end user or the customer might not understand the language at all. He might not know, right? He might not know how the Java works because he doesn't understand any kind of a programming language. He only understands the application, that some kind of an application is given for him, like GUI application is given to you where he can go and access that application. He can browse that application, right? So the developer cannot give the code directly to the end customer, or he cannot deploy that code, the raw code, into the production. Because if you deploy means you are copying the code into the production server also. You cannot execute that raw code, right? You need to have some kind of a machine understandable format, right, where that application will be running. So you need to basically build an application. You need to package and build an application. You need to compile that application, right? Compile it, build and package, and then deploy it. Once you deploy it, the machine or your server or your CPU will understand, so that it can execute that application. So it should be in some kind of a desirable format. The application should be in a desirable format. For example, in Windows, you have an installer, or we have a .exe, or in Linux or in Unix, you have a.out, right? Application output. Similarly, in Java, you have a COP format. These are all executable formats, we say, right? So your operating system can only understand the application whenever it is in a executable format, right? So each and every operating system can execute the program or the application when the application is in the executable format, right? For example, in Linux or in Unix, you need to have something as a.out. We call it assembler output. This is the format where the operating system understands an application. Similarly, in Windows, right, it understands either through the .exe or some kind of a DLLs, right? Dynamic linking library, right? Similarly, for the Java, it is nothing but it's a COF format. So you have various different executable formats. We call this as a executable domains actually, right? So now what happened, as a DevOps engineer, you need to understand, or you need to know the process of how to build the code and how to package it actually. Suppose a Java application is given, you need to understand, right, how I can build a package out of that code actually, right? So for doing that, you need to use some kind of a build tools, and you need to understand what are the commands are involved based on that build tool, and you need to like execute those commands to make sure that you finally get a get executable format actually. So that is what the that is what the DevOps engineer will do actually. So in between the developer and at the end user, you could see that there is some kind of a process is involved for doing this, right? Now, what is that process? We will see now actually, right? So let us write some notes now. So for any application, developers write the code, and the end user, or we can call it as a customer, uses that application. So what happens in between? In between means, what happens in between means, the developers, when he writes a code and until the application used by the customer, what happens in between? That's what I'm talking about. What happens in between is different for different applications. It differs each and every application, right? So it means that the way you do a build and package for the Java program is entirely different the way you build a package for the C++ program. Similarly, the way you build and package for the Python is entirely different the way you build for the Node.js application or for the JavaScript application. So you could see that for each and every different type of applications, there are various different types of applications are there. So whenever you want to do this kind of the build and process, though at the high level the steps are same, right? The steps are same. It means that okay, you need to take the code, or the process are same, but internally what happened, right? The things which you follow for is for different to different application, right? So what happens in between is different to different application types, right? And you know that we have a various different types of applications we have. We will discuss now. So now here, coming back to here, so what happened once the developer writes a code, right? So basically what happened, right? The DevOps engineer, what he does, the DevOps engineer, what he will do, he will try to create a package. He will try to create the package out of it. How to create a package means we will see now, we'll see later. So if it is a Java application, he might use a Maven build tool or an Ant tool. Basically nowadays we don't use the Ant tool, but we use a Maven build tool, because Maven supports a lot of dependencies. That's what like people usually go with, using a Maven build tool. So using a Maven build tool, okay, the DevOps engineer will create a package. Once the package is created, what he does, so what you can do that, you can create a package and you can give to the DevOps engineer. What he will do that, once he create a package, what he does basically, guys, he will try to download, or the user or the end user, he can even download it, download the package and install the application. Like for example, suppose assume that you are designing or you have developed the VLC player. So what you will do, once you complete the whole VLC development activity, finally you test it, and finally you try to put that VLC player.exe into some website, right? So where what happens, the end user can go to that site and he can download that as a package, the package, and he can deploy it, right? So similarly, what happened, the end user, he can take that package and he can install, or he can deploy into the system or the server, right? So this is what the very in a very high level I'm saying, right? This is what the people will do, right? So this we can call it as something like a desktop client, right? So in the desktop servers, right, or into your laptops or your desktops, so where you can download any software, right, and you can install it, right? So what happened right here, this comes under some kind of a what I say, desktop application, or you can call it a desktop or thick client application, thick client. Okay. So now coming back here, so there are different we can say application types, or there are majorly three different types of applications. So what are those types actually? So the first is nothing but we call it as a thick client, or we call it as a desktop applications. Okay, so if you want the examples, so we have examples like for example, you have a Chrome browser. Chrome browser is a desktop based applications, right? Or else you have something like a Microsoft Word. or else we have something the VLC player, VLC media player. So these are nothing but the client or the desktop based application. What is the other? Like the second one is a thin client, or else we can call it as a web based or browser based or web based applications. Right. So this is the second category. And what are the examples we have? So what are the examples, guys? Like we have something like facebook.com, we have amazon.com or portal.azure.com, right? So we will access any application through a browser, right? Through a web, right? Right. Already somewhere it is deployed. The application is running in a server. But how do you access? You give a complete URL, right? So as an end customer or as an end client, what you can do that you can access any of these applications, right? So by hitting a URL. So that is what we call the thin client or the web-based application. And the third category, even though it is not really required, but still okay, because it is something like nowadays you can even install any kind of a applications in your mobile also, right? You can go to your mobile and you can, if it is an Android, you can go to your Apple store and you can try to download any kind of an application, right? For example, you can download the WhatsApp, you can download the money control, or else you can download any kind of a TikTok application, anything. I mean, or else any kind of a banking, like applications, right? Like for example, your ICICI iMobile or HDFC banking, net banking application. So you can install it, right? Even in the mobile also, if you are very specific, you can categorize mobile also same as a thick client only. It is also like a desktop only, but still no problem. We'll try to separate as a separate like a type of application which comes under the application mobile. So examples are your WhatsApp, or else your MoneyView or moneycontrol.com, money control, TikTok, right? Or else your ICICI, iMobile Pay, whatever, right? So these are all the mobile based approach. So nowadays, like whenever we are developing the application, right, we also make sure that the developer also develops an application which works under the mobile device, either in the Android or either in the Apple OS, right? So it should either be deployed through your Play Store or else it has to be deployed through a App Store, actually, iPhone, Apple's iPhone App Store, right? So that's how we categorize this application to this different categories, actually. So whatever I said here, I mean, this is what usually a the DevOps engineer will do, that whenever any code is given, he creates a package out of it based on the application, right? He appropriately choose it. For example, if the application is written in the C language, so the DevOps engineers know that, okay, I need to use a make tool or an nmake tool to compile or to package it, actually, to package it, right? Similarly, for your Java, we use we use Maven, or else we can use Maven is a better tool, right? For example, if you are having a .NET application, we use some tool known as the MS Build tool, right? So each and every language has a different build tool which is available. So based on the application, the DevOps engineer will understand. He understand, okay, this is a build tool I need to use. And if he is not aware of the commands, he can either get the commands through the developer itself. He can ask the whole process of how to do a build and packaging everything. He can ask the commands and he can try to take out or use those commands, and he can do a build activity, right? So this is what the thin and thick based application. It will be similar for your web application also. Like web application, for web application it is not similar, because web application is something like you're accessing an application, right? If suppose the facebook.com, he does some kind of updates into his application, do you think that the URL will get changed? No, right? The URL will not get changed, right? Suppose the Amazon is doing some kind of a changes, right? So whether in case of a thin client web-based application, do you think that you do have to do any kind of a changes? Do you have to update anything in your system? Not really required. I use the same browser. the Chrome browser or whatever the browser, and I use the same URL what is given. So from perspective of the thin client or the web-based application, there is nothing like you need to do any kind of a changes, right? So usually what happened in the thin client side, if if the Facebook is doing some kind of a changes, so what they do it there, basically they'll try to do a lot of changes, and the server are updated with some kind of a new package. It's been that already the application Facebook is running, but the Facebook will try to install or upgrade some more new stuff. So by having a new package built out, and he will try to upgrade the existing application only. And whereas the user will access the application by using the same URL. So if you try to understand in this diagram format, right? So here we have a developer, right? The developer is there. So he's a developer, right? So this is nothing but your thin client or your web application actually. And here we have some we have an end user here, or end user or your customer or whoever who will be using the applications. So when it comes to thin client or web application, what usually happen, already what happened in the server, already that application is already deployed, like Facebook is already running, right? If you're doing any kind of updates to an existing to the existing application, so what the DevOps engineer will do, so already what happened, servers are updated. What the DevOps will do, servers will be updated with the new packages actually, or with new packages. Whereas for the end user, how that will be used, there's nothing changes from the end user. As I said that the end user will try to access the same application with the same URL. User will access the application using the same URL, right? So this is something like what we call as a web-based application or the thin client application, right? Okay. Same thing, even in app, in your mobile also, like in the mobile also, for what happened, right? Usually what happened, the updates are pushed to your app store or to your Google Pay, and the user updates that application by deploying it actually, by installing it. The same thing for the mobile also. So I don't want to draw the same thing, but it is same applicable even for your mobile also, mobile apps also, right? Okay, guys. So here what happened, usually what happens, so the servers are, as I said in the thin client, the server are updated with a new package. Server updated new package means what you do, basically you will try to do the code is compiled actually. You are going to compile the code. Code is compiled. So after the code is compiled, so basically you'll try to run some kind of a for compiling the code, you use the tool actually. Within the tool, build tool, you have some kind of a compiler. So that compiler is going to compile the code. Once the code is compiled, what happens, guys? You're going to create a package. You're going to create package suitable for the server deployment, right? So later what you go do, take the same package or use the same package and deploy into the server. Use this package and deploy onto the server. right? Finally, this is what the DevOps engineer will do actually. So I'm just telling in a very simple way. Right? So what exactly the DevOps engineer will do for the thin client application build or packaging? So what it does, guys? So code is compiled and then package suitable to app or web server, to the app or web server. Then this package, whatever the package we got, right, is deployed into the web server, onto the web server. So, I mean, deploy is what we call it as installing, or nothing but you're actually copying some set of files into a particular directory, we say, or into a particular folder structure. So deploying means basically it is copying the files, or you can call the code, into some directory structure or into some kind of a folder or directory structure. And if it needs some kind of a configuration, you need to even perform that also. So if after deploying it, if you want to further do some kind of a configuration, yes, we go to some kind of folder structure, go to some configuration file, .config file, do editing, save it, and do a restart of the service, like something like we do for the Apache server or Nginx. So what you do after post deployment of this softwares or the applications, what happened, right? You will tend to go to some file, right? For example, you have an etc Apache, right? Apache 2.conf file, like that you'll go, right? Or else if you have installed the SSL package, you'll go to the etc like Apache 2 ssl.conf. There are many configuration files are there where you need to edit the once you install the package, you need to do some kind of editing of the of the configuration file and then restart the service actually, finally. So this is what we as a DevOps engineer will tend to do this actually. Right? So if you take an example, like for example, this is one example. If you take any example, like for example, for the Java code, suppose you have a Java code and you know for the Java code, Maven is a build tool which is reneeded, and we will tend to use a Maven tool to build the code, and we will try to deploy the code or the package into to the Tomcat server. So if you take this example like this, you have a Java code, you need to build it and you need to deploy in the Tomcat. So you use a Maven as a build tool and we deploy the code to the Tomcat server, right? What are the process you do as a DevOps engineer? You will just say that, sir, get the code first. Okay, what are the developer has written? You need to get the code, fine, good. After that, what are you going to do? You're going to compile the code, correct? Compile the code. So you know very well that for compiling the code, for the Maven build tool, we use a mvn command. I'll use a mvn compile. So this is a command I use it actually. After it, what you do? You package the code, we say. So again, what you do? You use the same mvn command and you run a command by name mvn package. This is the command you run it, right? And finally, what happened, right? You will say that, sir, now copy the whatever the var or jar or year, whatever you get, right? If I say var file, take that var file. So once you do a mvn package, finally you will get a var file, right? You will take that var file, and what you will do that you will take a var file and deploy or copy into the Tomcat directory. What is the directory name? Web apps actually. So there is a web apps directory will be there. You will go to the Tomcat server where the Tomcat is installed, and inside that there will be a web apps directory. Go to that web apps directory and copy this var into or inside this web apps directory. This is what we will be doing it actually when it comes to your Java applications, right? Java with Maven with the Tomcat. Similarly, for example, if you have a .NET application, Okay, what you're going to do, you're going to do a build the code, and you're going to do a deployment of this application into the. So we use a .NET application. So to build a .NET application, use a MS build tool. Build tool is needed, and once the MS tool builds the package, actually you are going to deploy into the IIS application server. So what's the process? Same thing. See, the process is same. I mean, but what happened, right? When you but it differs from application to application. That's what I'm trying to tell you. Same thing. Get the code. Once you get the code, actually, what you do? You compile the code. So you know that now I'm using MS build tool. So what is the command you use? You use a MS build command, and you give the path to the code. Path to the code. Like for example, suppose you have something like a CS project there, right? Right? Under that, some directory, SLN is there. So you'll give this complete path like this actually to your MS build command actually. Once the MS build builds or compiles the code, what happened? You need to do a package actually. Packaging the code or package the code. So again, what happened that you'll use the same MS build tool. So what you'll do that you are going to use some kind of a drive and you give as a publish like this. So this will build the package. And finally, what happened? Now take this package. Now take this package and copy into some folder actually, into the folder. Like for example, if you take a C drive, under that I'm just taking some name, inetpub. You will try to go and copy that file under the inetpub and what happened? And configure it. And configure the IIS server. This is what you will be doing for your .NET application. Clear, guys? So what I'm trying to tell that here, the process is same actually, right? The process is same. Take the code, compile the code, package the code, and finally copy that code or copy that executable format into some data structure. This is what the DevOps engineer will do on a day-to-day activity, right? But it differs from application to application. The way you do the same process for the Python, it's not same for the Java. The code, the steps are different. But I mean, the steps are different. But in the high level, if you see overall, it's everything is the same. You take the code, you compile, you build, you package it, and finally deploy it. Actually, right? Clear, guys? So, what as part of this, what you can do, what you can understand is that actually, I think I told you yesterday only. You can find the steps. Actually, this is the exercise for you guys. So find the steps to deploy the Java application into the Devops server. I think yesterday I told this. You can even try out for the Tomcat, but I will showcase in the class like how to do a build and deploy the Java application and finally deploy the application into the Apache Tomcat. I'll be showing that as in a upcoming session. Find the steps to deploy the how can say deploy the Python application into the Apache web server. Yeah, you can try out this, guys. You can take up this activity and you can find out the steps. What are the steps involved in that? So right. So with this, what happened, right? We have understood. We have come across with some kind of a terminologies here, like for example, packaging. So it means that you need to package it. So what exactly a packaging means, guys? A package is something like it is converting the code into some kind of a deployable format. We say that we call a packaging, right? Yes, guys. Let me know what is packaging. So what is the packaging, guys? Packaging. Packaging is converting the code into some deployable format. That we call the packaging, right? And you also know that not all the languages are not compilable. You know that there are there are languages which need to be compiled. There are some languages which need to be interpreted actually. Like for example, you have a JavaScript, you have a Python, or you have a Bash shell script. These are all not compiled ones. These are interpreted code actually. We don't really do some kind of a compilation activity over there. You need to take directly the code or the script, you execute it actually. But whereas there are many languages, are there high level languages like C, C++, Java and all, where you need to convert that code into some kind of a deployable format. So it means that you need to basically build that code. Whereas there are many other languages are there, like for example, JavaScript or the Python, where you don't have to compile it actually. Those are all interpreted languages. So let me even write on those also. Package is converting. Okay, not all the application or not all the languages required the code to be compiled or the code to be packaged, right? Some languages expects the code to be compiled before packaging. Like for example, what are the examples? You have a C, C++, Java. What else? So you have a C hash. Many are there, right? Many high-level languages are there, etc. Right? There are some languages which doesn't need the code to be compiled, right? So examples, what are those examples? We have a JavaScript, Python, Bash scripts, etc. Right, guys? Do you agree with me? Any doubts here with this? Okay, no?
No, sir.
Okay, good. So, and one more very important, during this, the build and packaging and everything, right? The DevOps also, engineers also does some kind of a static code analysis. You might have come across with Jenkins, right? While going through the Jenkins, you have seen that once the code is built and everything, right? The code, the package will go under the static code analysis. It does go into some kind of a scanner actually. So you need to really verify how, what are the standards you have used to write the code, right? Whether it is meeting the standards or not, right? Whether like how many number of bugs are there in that, right? So those kind of code quality checks we do through a tool actually, right? And that tool, you know very well that we will be using a tool known as the Sonar Cube tool. So this is also one of the important that we have a static code analysis. I thought I will tell this about later, but it's okay. That's fine. Actually, we need to even tell about this also, because once you do a package, you don't take directly this package and deploy it, because the package, whatever you have, right, that has to undergo some kind of a code quality check. So it has to go to some kind of a code quality check. Code quality check. We call it as a, in the industry, we call it as a quality gate fix within. Okay. So why we use the static code analysis tool? Okay. So whatever the code, for the code that is written, the static code analysis tools will tell the best practices used actually. It means that whether you are meeting the standard, or suppose, for example, if a developer writes a code and if he introduce some kind of a loops actually, he uses in his code, if the developer in some logic, he used some looping structure, loops actually. Looping is not but something like a for loop or the while loop he uses. But during the static code analysis check, if he is using some 100 times iterative, he's kept the 100 iterations. It means that 100 times the for loop should run. But the static code analysis tool, right? It understand, okay, only 70 times only the iteration is run. 30 times there is no use of. So there's a wastage of the 30 times loop which is running, right? Here what happened, right? You are unnecessarily wasting the code execution time. So static code analysis will check that also. So that's what it does, some kind of best practice. It does a very nice code quality checks. And then it will give a report saying that, okay, these are the loopholes, or these are the standard which has not been met, or this is a variable which is not been used at all in the code, or this is the logic, or this is set of code which has never been executed at all. Suppose a developer writes a code. I'm just telling you, if a developer writes a 5,000 lines of code, and assume that actually there are some 200 lines are there which are never been executed at all during the execution of the application, it's a wastage of the code, right? Your code size will get increased, right? And it's unnecessary. These codes are never been executed at all. So what the static code analysis will do, it will even catch this point also, and it will give report to the user saying that, okay, this number of lines of code were never executed at all. So in that case, what happened, it will help the developer to optimize his code actually, and make sure that it consumes less memory, and it will be a faster execution. So that's what this tools, static code analysis tools, they're heavily used, right? And what are the examples? What are the tools examples for the static code? So we know, obviously, like there is a tool by name, what is it? SonarQube. There's a tool by name FXCOP. Somebody might have heard about this. We call it as a FXCOP. COP. MSSA. I have forgotten this. What is it, FSSA? But I remember this is also one of the tool actually, right? And whenever the developer writes a code, basically he does some kind of a testing on the code which he's writing, right? And that what we say we call it as a unit testing. So unit testing codes is also written by the developer only, right? So as a DevOps engineer, we will also make sure that the unit test, whatever it is getting executed, that should always get passed, right? So unit test, basically, it is something like we call the white box testing. Unit test also, these test cases or the tests are written by the developers only, are written by developers only. Because whatever the code he writes, right? So that code, to test the code, he writes some kind of a unit test actually, right? So even the even the DevOps engineer, when he's packaging, when he's building, and during the build process or during the package process, he has to even see that the unit test case are getting passed while the package is getting built, right? If it is not getting passed, if it is failed, then there is a serious error in your code actually. So why basically we are doing a unit test case? Because, right, for example, when a developer develops a code, and what happened if there is any like if there's any bug in the code, basically what happened, right? The bug will be caught by the testers actually. So by doing some kind of a manual testing, what happened, right? The bug might be recovered, or the bug might be found by the manual testing engineer. Assume that in some case, what happened, even the manual testing engineer has not catch that bug. Now what happened, the bug will be catched by some kind of an automation tool. Maybe he might have written an automation tool to test the application. So when you are executing that automation script, actually that script will catch that bug actually. So what happened, guys, whenever the bugs will be flown from the one stage to other stage, so the later you find the bug, it will be very difficult to resolve that bug. It means that it consumes a lot of cost also. It requires a lot of time also. That's the reason what happened. The developer will make sure that whatever early code which he writes, right, he can catch all the errors at the very beginning stage, at the very early stage. So to make sure that all the bugs are major of the bugs are not being caught by the testers or any other further engineers, right, he will try to write a unit test case actually. So unit test case is nothing but he'll write a code in such a way that it will catch all the basic, the basic building blocks of the code, right? If there's any bug in that, it will catch that also. So that is what, this is also very important for the DevOps engineer to make sure that during the build process, even the unit test cases should get passed actually. It should not get failed at all. If assume that if your bug is found by the, if suppose that nobody finds the bug actually, even the developer has missed to find the bug, even the manual testing engineer, even the automated automation engineer also, his automation also didn't caught that bug. Finally, assume that the bug has been catched by the customer, right? And that situation is very pathetic because it involves a lot of cost actually. If the customer finds a bug, right, then it will be a serious problem then. It means that somewhere, there is some big lag happened within your organization where people are not catching a bug actually, and the customer is finding it. And fixing that issue or fixing that bugs involved a lot of cost and time actually. So that is not a good practice, right? So we have met a standard actually. It means that 90% of the code, it should be bug free. You'll only allow only the 4% of the bug to go outside when you're releasing a product, right? You will expect, or the company maintain a standard, okay, we can allow up to 4% of bugs actually, not more than 4%. If a developer, if a customer is finding any bugs within that 4%, right, okay, it is acceptable, that is fine. But you cannot release a product to the customer or to the outside, right, with more than 4%, right? You cannot you cannot release any kind of a product with a 10% or 15% bugs. No, that is not a proper standard, right? So if you remember, like the Windows 98, right, Windows 95 operating system, which was released by our Microsoft company, right? It has a lot of bug actually. Even though the name says it is the 1995, I think it was not released in 1995. It was released in 1996, if I'm not wrong, right? This code, in a very hurry, they released this Windows because they were not able to meet the deadline target for releasing it. It was too late, and with a lot of bugs, what happened, right? This Windows 95 was released actually. Then when the end user, when the customer or when the people started installing this Windows 95 and they started working on it, they found so many bugs actually. Every day, like most of the customers were filing a bug actually. So either they found this bug, they found that bug, and it was too much actually, because it's not one or two, hundreds of bugs were found actually at the time. So now they make sure that, okay, whatever we resolve it, we will not release so many number of bugs with the product when you're releasing with the next version. So what Windows did, right, they released a very stable operating system in the Windows 98. So Windows 98 was very, very less because they followed all kind of a process to release it actually. So they even like follow the process of not releasing the product which is having more than 4% of the bugs actually. So 96% the code should be highly stable. So in that way, they released it. Microsoft released it, right? And if for the unit test, you know very well that there are so many tools are there, right? What are the examples? Can somebody tell you? What are the examples of the unit test? There are some tools, right? For example, you have a JUnit. You have a MS test tool. Some of you might have heard about Jasmine. In Python, we have some tools, a PyTest. So these are some of the examples of your unit testing tools, actually. So clear, guys? So now, yeah. So to just summarize everything, whatever we discussed, what is the workflow for your compilation and packaging? To summarize at the end.
Sir, I have a query.
Yes, sir.
Hello.
Yes, sir.
Yeah,
Good.
like you told us static code analysis or unit test code analysis, right? During the like build process or after the build, like the packaging time at the time of packaging.
Uh, I think there is some.
You got my question or not?
No. Your voice was breaking in between and all. Vinod, right?
Oh, no,
No, still your voice is breaking. Yeah.
no, Rahul this side.
Yes, Rahul, go ahead. Yeah, tell me, Rahul.
Yeah, I'm just asking. You told us the static code analysis and the unit test, like after the build, like in the packaging deployments, something like that.
See, unit test cases, unit testing will happen during the build time itself. Like, for example, when you're doing a MVN package actually, or MVN package, right? MVN package will do three steps. If you have gone through my Jenkins class, right? It does an MVN compile, it does an MVN test, and finally it does an MVN package. This single command will perform these three actions actually. MVN package when it comes to your Maven tool. So in case of MVN tester, so what it is doing, it is actually doing a testing, or it is executing the unit test cases, whatever the developers has written. So whenever the Java code is written by the developer, Java code, along with the Java code, the developer will also write the unit test cases also. So along with the main code, main Java code, even the unit test will also be present. So we will take the whole code, the main code, everything, unit test, everything will take together, and we will run a Maven tool onto it to build it actually. So once the compilation, everything is completed, once the unit test is, everything is successfully goes right, then what happened after that itself, actually what happened that you will be running a static code analysis. So where you have configured some kind of quality gate checks, right? So your code will undergo all kind of a static code analysis. There you have set a lot of parameters and everything, right? So once you have set the whole tool, your code will undergo the static code analysis, and it will give a report. It will give a report like where are they, if there are any bugs are there.
Okay.
If yeah, like that actually. Still you have not yet deployed actually. You have not yet gone to the deployment. Once the static code analysis goes further, then what happened, right? You will certify saying that, okay, that package, whatever the build is done, right? The package is fine. It is in a good state. So now you can take that package and then you can go ahead and deploy it. Or else what you do, that once the static code analysis is completed, for achieving the CI/CD process, what you'll do, you'll take that package and you're going to put under some kind of a artifactory, Nexus artifactory or JFrog artifactory. So those are artifactory tool where you'll push that code, the package, into those artifactory. So as a process, as a CI/CD pipeline process, we will do that actually. Or else once your static code analysis is completed, you can take that package, guys, and you can directly go and deploy into your server. That is what we do actually as a DevOps engineer will do.
Okay. Then what will become first? Like first or
Yeah, that's all. Let me write this workflow, then you'll understand. So first you will do the compile the code. Then what you'll do, you'll run the unit test section, run the static code analysis.
Excuse me,
Right.
sir.
Yeah.
So for code analysis, we use SonarQube, right?
Hmm.
Okay.
Correct.
Okay.
For so, yeah. Right. Static code analysis. Then what you do, deploy the package into some environment, into the test environment, testing actually. So once into the test environment. Once the testing is approved, once the testing is approved, it is deployed. Once the testing is approved, it is deployed to your UAT server, or else you call it as a pre-production server, or else in some means we even call it staging also. Pre-prod, staging, or UAT all are same actually. Right? So once this is completed, once you are deployed, once you are tested fine, finally you go and deploy into the production. This is what we do.
in which stage, like is the packaging the code?
Now compile the code means here it's packaging only, no? You're packaging
Okay.
everything. Yeah, compile the code means packaging. Sorry. Compile the code means what happened, man? Create a packaging. Create the package. Okay. So guys, it is almost 9:45, right?
Hello, sir.
Yes. So shall we continue
Sir,
other for, yeah.
sir, what is the difference between package and build? I'm not getting like.
No, build means actually, it is build. Actually, we say build is nothing but compiling. Compiling actually.
Okay.
Okay. Packaging something like where you will be doing additional task also. Like for example, apart from the compiling, you need to run unit test cases, and you need to
Okay.
even create some kind of a jar or var or er formats.
Okay. Okay.
Make sure everything what you do, right, you package it actually. We say.
Okay. Okay,
So
sir. Got
packaging will be a proper terminology to be used rather than using build. Don't use the build actually. Say it as a packaging.
Okay. Okay, sir. Yes.
Yeah.
Okay, sir. Got, sir. Thank you.
So what we will be doing now, like I was thinking to start with our 2-tier or 3-tier architecture and everything, but I think it'll be it'll take some more time actually. It'll take more than 45 half an hour time. So I think I can stop it today, and we can continue by not tomorrow, on day after tomorrow, same time I will take. So where we will discuss about the client and server architecture again. So this will be our next topic, client and server architecture. We already discussed it, but in a very high level, we'll get into one more level deeper into this, and then we have various different architectures. Like you might have come across with the 1-tier architecture, which nowadays we don't use it actually. We also have a 3-tier architecture, which again we don't use it actually, and finally we got a 3-tier architecture. Right? This is not, but this is the this we have to understand. So 3-tier architecture, or we can even call as an n-tier, more than 3-tier, n-tier architecture. This is what in the industry we use it actually, right? So this is what we have to understand. So maybe in the next session, right, we'll be covering this one and few other things also I will cover, so that we will be able to complete few of the things whatever I'm just thinking to complete, so I can able to cover up everything in the next class actually. This will hardly take me around half an hour to 45 minutes. So remaining time, I will cover up some other topics. Clear? Okay, fine, guys. So I think I'll stop it now. It'll be too late, and we will cover. We will connect day after tomorrow again, same time, 8:30 p.m. night. Wednesday.
Okay,
Clear?
sir. Sure.
Sure. Thank you all then.
Okay. Thank you, sir. Good night.
Thank you. Good night. Yeah.
Thank you, sir. Thank you, sir.
Thank you. Thank you, sir. Thank you. Good night.